हो गया पक्का सही बोल Hi everyone, welcome back to our channel Coders Arcade. This is Saurabh Sarkar and today we will be having our next Java session, the live session on operators. Okay, so let me just give you a brief recap about what we have done till now. So I will just write down the stuff that we have already covered. So we have covered the first one, that is arithmetic. Then we have covered the assignment. Then in the third one we have covered the, I think we covered the comparison, right? Yes. So this three we have covered, and as I had already told you, the assignment operators are also known as augmented and they are also known as shorthand, and for the comparison I told that they are actually called the relational operators also. Okay, so this much we have already covered in our previous live session. Guys, if you have not gone through this, I request all of you to please go through this live session. We have already uploaded the recording in the channel, so you can go through it and you can understand that and you can get back to this. Okay, so right now let's go to the next one. As I had already told you, today we will be trying to cover the fourth one, that is our unary. Then we will cover logical, and then we will finally move on to bitwise. Okay, this three we will try to cover in today's session. Okay, and out of that, as I had already told you, these are very important for any placement drives. Okay, because most of the times in the interviews we get questions on bit manipulations. So in that case, the bitwise operators becomes very handy to understand. Okay, so we will covering all these things in today's live session. Okay, and at the same time, guys, thank you for all your support. We are almost a family of 50k members, and I hope you will be following us and liking our videos as usual, and will be supporting us in future as well. Okay, so thank you for all your support and love, and hope you will be receiving the same in future. So without any more ado, let's get started with today's session. So I said we will be taking up the unary, the logical, and the bitwise operators, right? So let's do it. So the first one, or let me write 4, the fourth one we will go with logical operators. Guys, right now we are learning this in Java, and if you want you can tell that these are similar in C and C++ as well. Okay, but if you are talking about Python, here the logical operators will be a little bit different. Okay, we are not focusing on this, but I will just give you the syntax. So the logical operators are used for any logical operations. Okay, there are 3 logical operators. They are the logical AND, the logical OR, and the logical NOT, or this third one is also called as complement. Okay, and yes, these are the 3 logical operators that we have and that we most frequently use in any programming language. Okay, so we will be discussing that, and for that you have to remember the symbols. The logical AND symbol is let me just do one thing, let me erase this part for the time being. We will come back to that later, do not worry about that. Okay, so what I am saying is, for the logical AND, the symbol is double ampersand. Okay. For the logical OR, the symbol is double the symbol, and the logical NOT, the symbol is exclamation mark. Okay. So, these are the three logical operators that we have. Now, you might be wondering like where do you use this? Okay. I will tell you, when you have to compare 2-3 values and then you have to come out to a result, that is actually done using logical operations, and they are also sometimes known as Boolean. Okay. For that, you have to remember a very specific truth table. Okay. So, I will give you the truth table, and I hope you have learned this in your engineering. Okay. I will give you the truth tables so that you can follow along properly. So, let us take the truth table for AND. Just think like this. Okay. I will give you a very simple and straightforward thing so that you can remember this properly. Okay. I am taking two boxes, one will be for the and other will be for the OR. Okay. So, let me figure it out how to tell this to you so that you can understand in a better way. Okay. So, what we will do, we will take binary data like this, and guys, do not worry, we will talk about binary properly in proper session, maybe it is today only, do not worry about that. For the time being, I just want to show you something regarding the AND operator, how it works. So, as I said, for Boolean algebra, we have a truth table for AND and OR. Okay. So, sorry for this, let me just escape this. Okay. So, for Boolean, I will take 1, 2, 3 and 4. Okay. So, just remember one thing guys, for the time being, just remember like this. In programming, 1 is on, 0 is off, as I have already told you, right. In binary, 1 is on and 0 is off, or also you can say 1 is true and 0 is false. Okay. So, right now just try to understand this in a better way. So, I will say, I will write a truth table like this. So, I will say 0, 0, 1, 1, 0 and 1, 1. Similarly, and this is actually the output table. So, this will be the output, and for OR, here also I will do the same thing, exactly same thing. Okay. So, 1, 2, so this becomes 0, 0, 0, 1, 1, 0 and 1, 1, fine. So, now just remember it like this, when we say AND, just think like this, you and your friend, if both of them are going somewhere, then only you both will go. Okay. And it is something like, when both the inputs are true, then only the output is true, otherwise in all the other cases it is false. So, let me take a different color here and try to explain this. So, in only this case you can see this is 0, 0, that means it is false and false, right. So, here you can see 0 means false. So, when both the inputs are true, then only the output of the AND table is true. So, in that case 0, 0, false and false will be false, 0, 1, this is false and true. So, this will also be false, 1 and 0, true and false, this will also be false, and 1 and 1, this is true and true. So, only in this case it is true. Okay, clear with this? So, similarly, in the OR table, it is a little bit different. You remember this OR, just try to understand about this OR. OR means, if only one, if at least one of the inputs is 1, then the output is 1. Or to be precise, I do not bother about if my friend is going with me or not. If I am alone also, I will go, something like that. Okay. So, in that case, I can say that 0, 0, false and false. So, here nobody is going, right. So, it will be 0, 0, 1, at least one is going. So, 1 is true. So, 1, here 1, 0. So, 1 is going, 1. Here both are going, obviously both are going, they will go, right. So, it will be 1 only. So, just try to understand the difference, and we can do one more thing, we can just try to write it down like this in a different way. Okay. So, let me just finish up the table here, and we will try to replicate the same thing using true and false. Okay. So, what I will do, just let me show you something, 1 and 2. Okay. So, 1, 2, 3 and 4. Okay. So, wherever I have written 0, I will convert it to true, and wherever I have written 1, wherever I have written 0, I will tell it as false, and wherever it is 1, I will write it as true. Okay. So, that same truth table can be written something like this. So, I will say false, 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 true, true, false, true and true. Okay. So, in case of false and false, it will be false, false and true, false only, because 0 0 0 you can see. So, this becomes false, 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 and this is true. Similarly, this one let me write, let me take a different color here. So, I will say false, 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 true, true, false, and true, true. So, in this case it is, you can see 0 means false, all the others will be true, true, true. So, ultimately you can see, in case of OR, just remember like this, in case of OR, at least one input should be true. Okay, this is very mandatory. In case of AND, both inputs should be true. True means 1 you can say, or you can say T. Here in case of this also 1, or you can say T only. Okay, figured out? Did you understand this now? Now the same logic will be used in the logical operators. So when we are talking about this, see this here guys, logical AND. So only in case of AND it will be something like this. When I have 1 and 1, this can be any expression. Okay, we have already learnt about the comparison operators. When you are trying to compare 2 or 3 expressions or operators, then we will get this result 1, and whenever this 2 results are 1, then only we will get 1 for the logical AND. Otherwise, in case of OR, it can be 1 or 0, this will also be 1. And NOT, what does it do? It is actually doing the reciprocal. So the NOT table can be written something like this. I will just show you here. Okay, for the NOT table, it will be something like this. Guys, this is a little bit of theory, and we will go to the code, don't worry. Just for the time being, try to understand this. As I said, for the NOT table, this is A and B. So you can say input and output. So it will be like this, true becomes false, false becomes true. Or if you want to say like this, you can say 1 becomes 0, 0 becomes 1. So NOT is actually reciprocal. Ulta, the reverse. Okay, please remember it like that. So it becomes easy to understand then. So let me just show you some examples so that you can understand better. Okay, I will switch back to my IDE now. Here, let's take some examples so that we can understand about this even better. Okay, so let me take a simple example for you. So I will say S out. Here, what I will do is, I will take an example like this. I will say 1 greater than 2 and 3 greater than 4. So if you try to understand this, 1 greater than 2 is false and 3 greater than 4 is also false. So ultimately false and false. So if you go to this table here, so as I had given you the table, let me just go back to this table now so that you can understand. As we saw, false, false was false for the AND table, right? So ultimately false and false will result in false. Let's try to see the output. See this guys, we are getting false as the output. Okay, so in case of AND, only if both the statements are true, then only you will get it as true. Okay, let me just correct it now. Now you can see 1 is actually less than 2 and also 4 is greater than 3. So these two are correct, right? So in that case, let me just run this now so that you can understand this. See here, now you can get true like this. So you can also do one thing, you can take a Boolean value like this something like this. Let me show you here. You can take Boolean, say data is equal to 1 greater than 2. This is an expression which will result in 1 greater than 2 is false, right? So, this false value will be stored inside this. So, if I now try to print data, the value of data should be false. If I run this now, see the output, guys. Because 1 is not greater than 2, this is ending up into false, and this false value has been stored inside data, and this data, when I am printing, it is giving you a Boolean result which is false. Similarly, if I store this entire expression here, copy this and store it here, paste. Now 2 is greater than 1 and 4 is greater than 3. So, this AND will actually end up to become true, right? Because true and true yields up true. So, if I run this now, we will get the answer as true. Okay. So, logical operators are actually used to do some logical reasoning in the coding part. Okay. So, in a program, whenever you want to actually do some logical operations, we use the logical operators. Okay. So, out of that I have shown you the AND operator. Let me take the OR operator. So, here let me just do one thing. I will say 1 is greater than 2. Okay. So, this part is actually false, correct? 1 is not greater than 2, and 3 less than 4 is correct. So, false and true, when we say AND, as I have said, both the inputs in an AND operation should be 1, right? Both the inputs. But here 1 is false, 1 is true. So, ultimately it will end up in what? False only. If you see this, this becomes false, the second one. When I have printed the data, the second one is for the false one, right? So, here we are getting it as false. Now, but if I change this operator to the pipe symbol, guys, this vertical bar is called the pipe symbol. Okay, I will give you all the names, don't worry about that. Let us go to that, then we will properly discuss about that. But for the meantime, just remember this symbol is called ampersand. You already know, I guess. So, still I am writing it, ampersand, and this double slash or the vertical bar that you see, this is called the pipe symbol. Okay, fine. So, these are the two operators. Now, when I am using OR, what I have told you, at least one of the inputs in the OR operation should be true or 1, right? In that case, 1 greater than 2 is false, but 3 is less than 4. In this case, this one is true. So, false or true should be giving me true as the output. Now, if I print data, just see the output now. Now, you can see we are getting this as true. Clear? So, this is how they work. And if you want to reverse something, then we use the NOT operator. Say suppose now we are getting true as the output for this entire expression, right? Now, if I put this entire thing into a bracket like this, and now if I run this, you will get the same thing no matter what. But what I want to show you is, if I say convert this into the NOT operator, right now we are getting true, right? If I take the exclamation mark, this gives you the NOT operation. Okay. Now, the result of this thing is true. When we do NOT, it does the reciprocal. If I go back to this one, you can see here, see, true becomes false, false becomes true, 1 becomes 0, 0 becomes 1. So, in that case, when I actually do the reciprocal of this operation, this should give me false. Right now it is true. When I run this again, it should give me false. So, NOT operation is done to reverse something. Okay, 1 becomes 0, 0 becomes 1, and it is actually the reciprocal. Clear with that? So, these are the 3 logical operators that we have discussed right now, the AND, the OR, and the NOT. Okay. So, let us go back here and just take a simple recap. So, we have learnt about the AND operation, we have learnt about the OR operation, and we have learnt about the NOT operation. Okay. AND is, this symbol is the ampersand, this symbol is the pipe symbol, and this is obviously the exclamation mark. You already know it from English, right? Fine, clear with this? Now then, after this, let's go to the next operator. Guys, if you are having any doubts, please post your doubts in the comment section. I will go through them and I will get back to you with that. And if you are watching it live, then obviously you have to comment it now itself. So I will watch them and I will share all the doubts that you are having. Okay. Now let's do one thing. Let's go to the next operators. The next operator here we have is the unary operators. Let's take a different color. So here we will be discussing the unary operators. Guys, these operators are actually having the symbols plus plus and minus minus, and also they are also known as prefix, postfix. Sometimes they are also known as increment, decrement operators. Okay, they are used to increase or decrease the values of variables. Okay, and you will very frequently use them inside looping statements also. We will talk about that in our further classes about the looping statements. Don't have to worry about that. For the time being, just remember that plus plus and minus minus are actually increment and decrement operators. They are also known as prefix and postfix, or they are also known as unary operators. Okay, they increase or decrease the value by 1. Okay, let's see an example so that you can understand. So I'm going back to my editor, and here let me just delete all these things that we already have here. Fine. So what I will do here is I will just write something like this. Just give me a moment. Okay. So here I will just type this. I hope the screen is visible. Okay. So let's give a simple example so that you can understand. Guys, many students face a problem with this operator. So I'm going to clear it once and for all. Okay. Just try to focus on this. So I am taking a variable int a is equal to 10 and int b is equal to 20, and I am saying s out. I am saying a plus 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 b plus plus. Okay. Now what do you think will be the values of this operation? Some people say that it will be a plus plus means 11 plus this b plus plus means 21. So ultimately 21 plus 11 should be giving us 32, right? But that is not the correct answer, guys. Many times I have seen people telling this as a wrong answer. Okay, so just try to understand this, what I am saying. See, the answer is not 32, it is 30. Okay, just try to understand what I am telling now. I'll go back to my editor. So just see this. There are two types of this. You have seen this, right? Prefix and postfix. So when I have a equal to 10 and b equal to 20, in that case, when I say a plus 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 b plus plus, actually the initial values of a and b are taken and they are added. So ultimately it is 10 plus 20. That's why it is 30. Okay, whenever we are writing this. So this is called postfix. Okay, so the current values, whatever values are already there, they will be taken and then the operations will be done, and this will be the data. But if you go to the next line, in memory a has been incremented to 11, b has been incremented to 21. If you don't believe me, let me just show you here. Here if I just print this, say s out, a is equal to comma a, or let me just say plus a plus, let me give a space, concatenation, I will say b equal to plus b. Okay. So I just want to see the values of a and b. Are they even updated or not? So that's what my target is. So here in this line we saw that the value was 10 plus 20 is 30. Let me run this now. Now we'll see the magic and try to understand this. See guys, as I told you, let me give a space here also. Here I can give a space, right? Yes. Let me run this now. Now you can see in the first line, the current values which are 10 and 20 have been taken from the variable and they have been added together, and we got the answer as 10 plus 20 equal to 30. Okay. This is in the postfix method. Okay. And after that, in the memory, the values of a and b have been updated to 11 and 21. Make sense? Please, this is a very important thing to understand. But if I had done this with the prefix, okay, prefix will be something like this. Okay, let me just explain it here. If I have done it regarding the prefix, now if I have a equal to 10, b equal to 20, prefixes, remember the symbols will come before the variable. Okay, so it will be plus plus a plus b, something like this. Okay, so not only in the memory but also in this execution line the values will be updated. So this will become 11 and a has 11 in memory, and this will become 21. So b also has 21 in memory. So plus 1 incrementation has been done in both the variables. Okay, now finally you will get 11 plus 21 is 32, and in the next line if you print them, you will get the values a equal to 11 and b equal to 21. Make sense? Did you understand this? This is prefix. Please remember this guys. Many students, believe me, I have been to many engineering colleges in Bangalore and I have heard this from many students. They don't understand this silly concept. It is very easy and simple to understand. Okay, I hope you have understood this now. Now let's go back to our IDE and try to understand this better. Okay, so what I will do is I will just remove this from here and write it here, say plus plus, and here I will use plus plus. Okay, let me close this part. And now as I told, here in the memory a will become 11, b will become 11, and in this line also the value of a will be updated. Earlier you saw that it is not updated, but here it will be updated. Okay, so if I run this, now this line should give you the answer as 32, and here it is a equal to 11 and b equal to 21. Let's run this and see. Okay, you can see this, right? So I hope this is clear now about pre-increment and post-increment. So these are the unary operators, and similarly there is minus minus. So guys, can you just tell me the answer for this? Let me just see if you have understood this or not. If I say minus minus a and minus minus b, minus minus b, what will be the answer now? I am saying minus minus a plus minus minus b. That means what is minus minus a? Post decrement or pre decrement? It is pre decrement, right? So 10 becomes 9 and 20 becomes how much? It becomes 19. So when you add them, 9 plus 19 becomes 28. Okay, so here we should get 28, and in this line it should be updated to 9 and 19. Let's run this and check. See guys, clear now? So this is how your unary plus plus and minus minus operators work. Okay, they are also known as prefix and postfix. I hope you have understood this in the proper way. Any doubt, any silly doubt, guys, a doubt is silly as long as it is not asked. Okay, because it's about your career, so you have to ask those doubts. If you have any silly doubt in your mind, please ask them. And guys, if you are really liking the video till now, please give this video a thumbs up and subscribe to our channel if you are new to the channel. Okay, thank you. So let's do one thing. Let's go back to our whiteboard and try to understand the next operator that we have. Okay, so I hope all this increment and decrement operators are properly clear. Okay, now let's go to the next operator, which is our bitwise operator. Okay, so I don't think I will be able to finish this off today. what I will do is, I will give you a brief introduction to binary, because computer only understands the binary language, as we have already discussed, right. So, let us do one thing, let us learn about the bitwise operators, but before learning about the bitwise operators, we have to learn what is binary. Okay. So, right now in today's class, I will give you a brief introduction to what is binary, and after that in the next session we will be covering bitwise operators properly in detail. We will have a dedicated session on bitwise operators only. Okay, fine. So, as I said, we are learning a high level language which is Java, but when we write this code and when we actually give it to our compiler, what does it do? It converts it into something called binary, but we do not understand this binary language, right. This is totally out of our control. We do not understand this, because I cannot speak like this. I cannot say 10101010 something like that. We only understand our language, whatever we are learning. This has been feed into our brain, so we can write this language and understand this language. But the computer or our PC, it only understands the binary language. Then how do you understand this? There is a very simple trick to understand binary. I will tell every single trick in this session. Okay. So, let us do one thing. Let us try to understand what is binary language first. Okay. So, just think of this numbers. What I will do is, I will tell you this secret to understand and remember binary. First of all, binary has 2 digits, that is our 1 and 0. Initially, what you do is, say suppose you have to convert something from decimal to binary. Say I have a number called 25. What I do, I just divide this number by 2. Okay. So, just see the trick. 2 12s are 24. 2 12s is 24. The remainder is, you have to write the remainder every step. The remainder is 1. Okay. After that, 2 6s are 12. The remainder is 0. 2 3s are 6. The remainder is 0. 2 1s are 2, the remainder is 1. Clear? So, for every odd number we have a remainder as 1, and for every even number, obviously when we divide by 2, we will have the remainder as 0, correct? So, in that case, this number or this bit is called the most significant bit, and this final one is called the LSB, or the least significant bit. Okay. So, this is also called the MSB. So, when you want to write this as binary, the binary will be starting from this one and going till here. So, it is 1 1 0 0 1. Fine. Clear, right? So, the binary for 25, the decimal number 25 will be 11001. Okay. Similarly, say suppose you have a different number, say let us take a simple example, one more example. Okay. I hope you have understood this, right? Just divide the number by 2 and keep on writing the remainders, and then finally start from the most significant bit and go till the least significant bit. Okay. So, this is binary to decimal to binary, sorry. So, what I will do, now I will take another number, say 341. So, here let me just say 2. 2 17 2 is 34, this will be 0. Okay. So, what is the remainder? The remainder is 1, because it is an odd number. Okay. Then I will take 2, how much? 2 8 is 16, 1 85, this is 0, even number. 2 I will say 2 4s are 8, 2 2s are 4, then remainder is 1. 2 20, how much? Sorry, yeah, 21 only, remainder is 0. 2 10s are 20, the remainder is 0 or 1, odd number, right? So, remainder is 1. So, ultimately here it is 2 5s are 10, remainder is 0. Then it is, let me just drag it a little bit up. 2 2s are 4, the remainder is 1. Then we have 2 1s are 2, the remainder is 0. So, ultimately from here we will start, from this 1 will start, it will go till here. So, ultimately it will be 1 0 1 0 1 0 1 0 1. Let me check, 1 0 1 0 1 0 1 0 1 1 0 1 0 1 0 1 0 1. Yeah. So, for 341 the binary is this. Okay, clear? So, this is how we can convert a decimal number into a binary number. Now, suppose you are given a number like this 10101. How do you find out the decimal equivalent of this number? This is a little bit tricky, right? Because now we only have ones and zeros. Here we had a simple number. So, I said we can divide it by 2 and we can get the binary, correct? But here we have a binary number. This is in binary, ones and zeros. Now, how do you get the decimal equivalent of this number? It is not so easy. So, for that I will make it very easy for you to understand. Just do one thing. Just remember this table and your life will be very easy from now. Okay. So, I am taking something like this. Let me say, write down 1 here, double of 1 is 2, then I will take 4, double is 8, then I will take 16, then 32, then 64, then 128, then 256, then you can go on 512, you can go on 2024, 2048, 4096 and keep on going like this. Okay. So, it is just a double, fine. Now, say suppose these are actually switches, and these switches you can actually turn on or off. Okay, you can turn the switches on and off, fine. Just remember like this. Say suppose now I want to represent 0. So, in order to represent 0, is there any number called 0 in this? No, right? So, right now we will take a 4-bit representation. Okay. So, I will say 1, 2, 3 and 4. Because 0 is not there, I have taken a 4 zeros in this. Next, let us go to 1. Is 1 available here in this table? Yes or no? 1 is available in the first column only here from this side. So, this will be turned off, and I have already told you in programming, turning on and off is done by using 1 or 0, right? 1 means on, 0 means what? Off. So, this switches, whenever you turn on and off, you will write 1 or 0. Whichever you are turning on, you will write 1, whichever you are turning off, you will write 0. Okay, makes sense? So, what I will do, for 1 I have to just switch on this thing. So, I will just write 1, all the others will become 0. Clear? Now, let us go to the second one. Say suppose I want to represent 2 now. So, 2 is already available readily. So, this switch will be on, all the others will be off, right? So, this becomes like this 0 0 0, sorry 0 0. This switch I want to represent 2, so it will become 1 and this will become 0. Make sense? Now, interesting is 3. 3 is not there in this table. Now, how do you represent this? We can add up, okay? That is the thing. 2 plus 1 gives you 3. So, ultimately, whenever you can add up, just put them, those switches as on, okay? So, what I will do, 0 0 1 and 1. See, make sense? 2 plus 1 is giving you 3. Now, let us go to 4. So, for 4, we already have 4 here. So, what will be it? It will be 0 1 double 0. Make sense? You are understanding what I am doing? So, suppose you want to represent 8. Can you tell me how will you do this? Say for 5 it is very simple. 4 plus 1 will give you 5. So, ultimately it is 0 1 0 1. This is how the binary works. And guys, to be very frank, what is actually this thing that I have written? What are these numbers that I have written? They are actually to the power of 2, the power of 2 actually, starting from 2 power 0 to 2 power n minus 1. So, here whatever you see, this is actually 2 power 0, which is 1. Then this is 2 power 1, 2 power 2, 2 power 3, 2 power 4 and it will keep on going like this. Okay? 2 power n minus 1. So, 2 power 0 to 2 power n minus 1. That is why all our binary numbers can be represented by this power of 2. Clear? And now, as I had already told you, can you guys tell me how do you represent the number say 15? We are talking about 15, 1, 5. So, in order to represent 15, you have to do the calculation. So, 8 plus 4 is 12, 12 plus 2 is 14, 14 plus 1 is 15. So, if all the numbers are utilized, in that case obviously you can write like this 1, 1, 1, 1. This is the binary equivalent of, this is 5 and this is 15. Clear? This is how guys we actually use our binary. Hope it is clear guys. So, for the time being, whenever someone is giving you a number like this, say 10101, what you do is you write like this 1, 2, 4, 8 and 16. Fine. Then wherever you have 1 in the values, just take that number 16 because this is on, right? Then 4 plus then this 1. So, this becomes 20 plus 1, that is 21. If you want to verify, you can just do like this. Let me just take the eraser. We will verify this in the reverse method. Okay. So, here what I will say, I will write 21 and try to divide this by 2. So, 2 tens are 20, the remainder is 1, 2 fives are 10, the remainder is 0, then 2 twos are 4, the remainder is 1, then 2 ones are 2, the remainder is 0. Okay. So, here if you see, if you start from this digit and go till this digit, it will be 1 0 1 0 1. See 1 0 1 0 1, and that is what we have written here also, right? How much did we get? This number is 21 and here also this number is 21. So, practically I have verified that the binary of this number is 21, just like the method that we have learned earlier. Clear? So, this is it about binary guys. Now, in the next session, we will be learning properly about the bitwise operators, because now you know properly about binary. Okay, and as a homework, you guys just can take up some numbers on your own and try to convert those numbers into binary by dividing by 2, and also take some random numbers like 10 10, random numbers in binary, and try to convert them into decimal by using the logic that I have told you. Okay, and in the next class we will be covering up the very important concept called bitwise operators. Okay, so stay tuned for this, and I hope you have liked this video today. If you have any doubts regarding any single part of this video, please ping your doubts in the comment section. I will be very happy to clarify them. And thanks for watching guys, and thanks for all the love and support that you are giving. And at the end, I just want to say one thing. आप लोगों का कुछ नहीं जाएगा, एक शेयर कर दो, एक लाइक कर दो, एक सब्सक्राइब कर दो, if you are new to the channel. Thanks a lot for watching, and this is Saurabh signing off. Till the next time, till next Saturday, I am signing off. Bye bye and happy learning, and thank you for joining us in Coders Circuit. Bye bye. Thank you.